Well, welcome to this evening of computer science at Caius. We're going to have essentially a conversation between 5 Caian computer scientists. It turns out that this is my 50th year as a member of Caius. You can tell when people are getting old because they say they're in their 50th year rather than I've been here 49 years. Anyway, this is my 50th year, and I thought 5 decades was quite interesting. And so we've invited people back from each of the decades. So I represent the 1970s, and I arrived to read mathematics as an undergraduate. There wasn't much of a computer science undergraduate course then, and I just migrated into computer science after graduating. Quentin Stafford-Fraser arrived in 1986 when there was a 2-year tripos. You had to fill in for a year first, and Quentin spent a year doing engineering, took 2 years of computer science, and has then had a varied career in research, startup companies, consultancy, and starring on the Caius alumni team for University Challenge, which they won. Although I probably shouldn't embarrass Quentin by saying that he was the one person who failed to answer the single computer science question in the evening.
Geoffrey Moore. Geoffrey Moore invented Moore's law.
Yes. We don't let him forget. Isabel Luckett, Isabel Kingsville as it was, came to Caius in 1998, and after graduation went and worked for many years in industry, indeed as an official secret. So I can't really tell you much about what she did, but I was visited by men in grey Macs to ask me about her before she did it. Recently, she's moved across into a startup working in cybersecurity, and we'll talk more about that later. Ian Davies arrived in Caius in 2004, stayed around as a postgraduate student and postdoc, and recently co-founded a startup here in Cambridge with another Caian, and they seem to be doing reasonable business, albeit still from his bedroom, I see. But anyway, that's mainly because they're locked out of their office because of COVID. And then finally, Paula Buttery joined Caius in 2013, although to be honest, she had been in Cambridge slightly longer, arriving at some other college that we won't mention just across the road from where the department now is in the 1990s. And she's now Professor of Language and Machine Learning in the department. So we are some of the Caian computer scientists. There are many more that we would have liked to invite, but we think we probably will fill an evening between us. So we'll actually end by taking questions. So there's a question form somewhere on Zoom that you can fill in. Do file questions at any time, and we'll try and pick them up towards the end of the evening. I should say the initial discussion will be recorded. It is being recorded, but we won't bother to record the questions and answers, so we can all be fairly frank then. So we thought we'd start by reflecting a little bit on, well, how technology is different nowadays. Paula and I were interviewing admissions candidates just before Christmas. And of course, this year of all years, we had to rely on technology. But when I was interviewed back in the late 1960s,
you didn't have technology back then.
Called up to Caius, and I was actually interviewed by 3 people simultaneously in a room on the ground floor in Tree Court, which had an open fire, a coal fire burning. And of the 3 people there, one of them chain smoked cigars. So when I arrived for my interview late in the afternoon, I couldn't see across the room. It was the temperature slightly warmer than a furnace, and I was sat in a deep armchair with wings that enveloped me, and questions came out of the fog at me. I think I managed to avoid talking about mathematics, so I got in, and this has seen me going well since. But of course, this year, we had to do it all like this, online, which entertained us because we had additional problems trying to ask questions that were of a mathematical nature, which you can't really do without pencil and paper. And so we tried to use various technologies, remote whiteboards. And well, Ian's a bit of an expert on this, so he was going to show us a bit of the sort of technology that he uses successfully. We rather failed at the interview, I have to say.
Well, I think it was reasonably, most people agreed that actually the remote interviews went much, much better than we thought they were going to go, which might just be a comment on how badly we thought they were going to go. But I think, yes, Paula, Peter and I all interviewed this year, and it mostly just worked. And we used, iPads, which have extremely expensive pencils that go with them, and actually they're a delight to use and remarkably easy to interact with people remotely. And we were chatting about this the other day and realized that there are still bits of technology that we are amazed by that they work. And this technology has been around for a little while, but if we were trying to do this even 3 or 4 years ago, I don't think we would have had anything like the success. Video conferencing has come on a long way, and the interaction design that's gone into things like the iPad and the shared whiteboards that we use now really has come on a long way. But actually, this has been going on for a long time at the computer lab, and indeed by people who are on this call. Quentin, I imagine, has some things to talk about with the Brightboard that he worked on, and Peter with the light pen and things like that that came before. So this technology that we've used this year has been a very, very long time in the making. Quentin, do you want to show your delightful?
Oh yeah. Well, this is back when I had some hair. This was from my PhD work, and I apologize for the quality of the video, but let's see whether this works. You can probably tell.
There are many situations where it would be useful to have access to the facilities of electronic documents, the ability to print, fax, save, or email, but where typing at a computer might be difficult or inappropriate. In a brainstorming meeting, for example, it's much more natural to jot down ideas on a whiteboard, but then they don't have all those useful electronic properties. Brightboard is a system which allows documents on ordinary drawing surfaces to be endowed with many of the capabilities of their electronic counterparts, using the drawing surface itself as the user interface. This means I don't need to be distracted from the focal point of the meeting by a keyboard, screen, and mouse. For example, suppose during the meeting, somebody requests a copy of the diagram. Using Brightboard, I can write the print command directly on the board. Activity on the board is being monitored by a camera, suspended from the ceiling and connected to a computer next door. I stand aside to give the computer a clear view, and when it sees the print command, it uses synthesized speech to tell me so. I can then delete the command and carry on. Using similar commands, I can fax, email, and save the image, and I can also control other devices. I might adjust the air conditioning, for example, simply by writing the required temperature on the whiteboard. Or I could select one of the popular views on our audiovisual network. VP stands for View the Park. I have all this control from the front of the room. Finally, Brightboard can be used on any drawing surface, not just whiteboards. Here, a camera clipped to a bookshelf above the desk allows me to create a desktop scanner and photocopier.
There you go. So yes, I did have hair once, but this was all part of what we were starting to call augmented reality by then, by which we didn't mean, wearing headsets. We meant taking reality and can you give physical objects some of the attributes of digital ones, like the ability to...
I've got to ask, how on earth did you recognize the writing on the whiteboards at that point? We're not very many deep neural networks and things.
Oh yes, it was terribly. No, I did actually try doing a neural network because I had just heard of them at that point. But no, there was, but it didn't work because I didn't really know anything about them. No, I wrote a very, very simple character recognizer, which could only recognize about 10 different symbols and not very well. But it actually worked well enough, and it used things like, you know, it found the blobs on the board, and it used things like where was their center of mass in terms of their bounding box, and how many black pixels were there with white above them compared to black pixels with white to the right of them, and things like that. So it was very crude, but it actually did the job. And then the funny thing was,
probably wouldn't have generalized to self-driving cars, but worked perfectly well.
That's right.
I think what's fascinating there is you see how advanced in practice what you were doing was, right? And actually you fast forward quite a lot of years, and while some of the building blocks we have evolved massively, right? So Ian, you held up your iPad and your pencil, right? And they are beautiful to write on. But what I don't think has evolved so far, probably through lack of need, is that whiteboarding experience, right? And how you bring that to the virtual domain. And actually there's an interesting question from Oliver in the chat who says, the remote interviews sound fun. Did the candidates all use iPads too, or were they stuck holding paper up to webcams? So I don't know whether Peter or Paula or Ian can add any interesting anecdotes to.
Yeah, we had a bit of a combination of things going on. Our attempts at them using the iPads that they were given, they weren't iPads. What were they, Peter?
They were the cheap and cheerful £35 graphics tablets from Zuma Graphics, I think.
Yeah, that's right. But the
as you pointed out, it was cheaper than them buying a train ticket to come to Cambridge for an interview.
Absolutely, yes.
Which is quite a challenge. Sorry,
but our experience wasn't terribly brilliant, was it, Peter? Because the whiteboard on the video conferencing we were using didn't actually tell you where they were, didn't show you the same view.
That's right. So the whiteboard had an infinite field of view, and the candidates had one window, and I had a different window, and Paula had another window. And all I could see on my screen was a little arrow saying, he's over there somewhere. And I had to go and hunt him down. So actually, yes, Ollie, we ended up getting them to write it on paper and hold it up to the camera. It was far more reliable.
I actually had a different experience. We got people to, we gave them the choice. They could either, we hadn't sent them graphics tablets, so we said they could either use the mouse to interact with the whiteboard, and we'd actually quite carefully picked the questions so that they could do things like copying and pasting chunks of a diagram to build various bits of computer architecture, and that worked quite well. And in some cases we said, you know, if you would rather write on a piece of paper and hold it up to the camera, then feel free. And a couple of people did that, and that worked just fine as well. So actually, yeah, it went okay.
You know, it's long been a bugbear of mine that we can do so much now with this interaction over a distance, and we can send each other video clips, audio clips, URLs, chunks of markdown, whatever it may be, but we can't really, in most situations, draw anything. And that's partly because the mouse came along. You know, we used to use light pens, and then the mouse came along, and for most situations it was easier to point at things with the mouse sitting on your desk, less tiring on the arms. But we used to have ways of drawing on the screen, didn't we, Peter?
We did, yes. So actually, here's a picture of me when I had hair on the top of my head, not on the front. So this is back in the mid 1970s. Quentin's work on cameras was in the 1990s, so 20 years earlier, about 1977 this was. I'm using a display there called the Vector General Display and interacting using a light pen, which is that strange thing I'm holding in my hand. You have to hold it up against the screen, so you've actually got RSI holding it and interacting for too long. And I think with luck, we even have a video clip of my late wife Carol, who I met over the Vector General computer display using it. And so this is how you did graphical interaction in the 1970s. So it's a mixture of typing on the keyboard. You can see there are menus. Some menu items are actually near to where you're working. They just follow the cursor around. So these are rather like pop-up menus, you might think. And there are fixed menus at the side that sort of change the modes that it's operating.
But amazing, right, that nearly 50 years on, this feels quite familiar. Right?
Well, it's even more impressive. I mean, there's been work done very similar at MIT, similar sort of interaction. What's in this program is rather more clever, but 15 years earlier with Ivan Sutherland's work on Sketchpad. in fact, Carol's research was into grammars that describe data. And the point was that as you edited a data structure, its grammar remained correct, which is sort of vaguely sits underneath some things to do with databases today. Perhaps what's more extraordinary is that was being done on a computer that had 64 kilobytes, count them, 64 kilobytes of main memory. And was, well, indeed, the work that you did on it, actually, if we remove that now, Quentin. So here's actually the, with luck. No, wrong picture.
Sorry, wrong. Sorry,
you go away, Quentin. Let's just ignore you. No, that's wrong picture too.
Oh, sorry, sorry.
I just want my camera. Thank you. I was going to show you something. So with luck, I'm now showing you. This is the light pen. I still got it. Doesn't work nowadays. So it has a lens there. That's a photo detector. It's plugged into the gubbins. But you have this computer with 64 kilobytes of main memory, but you had to have, of course, a disk on which to store your information. This is the disk, looks a bit like the Starship Enterprise. This is a 2 megabyte disk, 2 megabytes. So that, it turns out, was sufficient to store the operating system, the compiler, the work that I was doing for my research, and indeed the entire text of my dissertation, all in 2 megabytes. And you could tuck it in your pocket, just like a memory stick, and take it home with you. But even that was a step up. At least it was interactive. We actually had text editors on the screen. Actually, we were very lucky. We had those using that display. Most of the work in the department in those days was done on preparing things on punch cards for an IBM mainframe computer. And Quentin again has I think, a picture of one of these. This is a card punch actually that I'd used even when I was first doing computing at school. And you can see there a card. It has 80 columns of 12 rows, and the card punch has 12 keys. You learned how to play chords on the card punch. Single keys for digits, 2 keys for alphabetic characters, and 3 for punctuation. Semicolon, even now I can remember, was 0, 3, and 8 simultaneously. And this was great because if you needed to edit your cards, your program, you could remove a line of program from one card and shove a replacement in. In fact, if you were lazy, you could even edit the cards themselves by filling in the holes. As you punched out the holes, the X holes dropped out of the bottom of the punch, and you could pick them up with a very inky biro and put them back in the card, and they'd probably stay there for a while, long enough to run through the card reader again. Or at least that worked until they got a new extremely high-speed card reader that took the card through a very sharp 180-degree turn in the middle. And all of these little bits of cardboard, chads as they were called, flew out because they weren't actually glued into place and blocked the light sensors. That made me very unpopular with the computer operators.
How on earth did you debug programs?
Yes, well, when I first programmed, you punched your cards on at school, and we posted them off to have them processed. They were run and the results returned to us. So you had about a 1-week turnaround on doing a trial run of your program. So you learnt to think before you press the run button, as it were.
Unless you were lucky enough to be able to debug, presumably by filling in the little holes if you'd made a...
Oh, well, yes.
When they sent the cards back, you would paste something in.
Oh, no.
You'd be working out which hole, right? How on earth?
Oh, yes. Well, now, it was much easier with the other mechanism that was more popular in Cambridge in those days, was actually used paper tape. This had been the way that the EDSAT computer had worked. So this is a long strip of tape, 1 inch wide, and it's got room for 8 holes across it, so you can get exactly 1 byte. The trouble is, if you make a mistake in the middle of this, it really is much harder to splice, put it all back together. So it was a great, when I first arrived in Cambridge, the university computer, the Titan computer, more or less homemade, loosely modelled on a Ferranti machine, was still in use, and you had to punch things on paper tape, which was more tedious, because if you made a mistake, you had to sort of copy the tape and then remember to put a new bit into the middle of it, which was much more difficult.
Peter, you have a comment in the Q&A from Chris saying, don't forget to mention dropping a card deck.
Ah, yes, dropping packs of cards was a problem. So you learnt various tricks, like putting, as you had a thick pack of cards, you'd draw a diagonal line across the side of it with a felt tip pen, which meant it was moderately straightforward to get those back into the into a straight line when you lost some, but not always.
And you have to get one out of order.
Oh, and we've got Philip saying you could cut off the edge of the tape to delete. We've got some
well,
lovely
if you punched all the holes out across a row of tape, it was a delete character and it was ignored. Oh yes, so someone asked, did we ever have the problem with Chads getting lost in the way of American elections? No, the punch was a much better one than their voting machines.
Do you know, I do remember somebody telling me a story about paper tape, which I thought was you, Peter, but I think you said it wasn't. So maybe it was Roger Needham or someone, about competitions of, there was a reversible paper tape reader, and competitions where you would shoot the tape through in one direction, stop it and shoot it back out in the other direction before the end had sunk down and touched the floor. And there was a competition as to who could make it go the farthest. And the problem was that they were trying to get it faster and faster, and the tape, if you punched the tape with lots of holes, it was more fragile and it wouldn't run for as long. So the trick was to write the code on the tape that was going to and fro and use instructions that didn't punch too many holes in the tape, because then you'd be able to keep it going further and longer, which I thought was wonderful. But you mentioned Titan though, Peter. Oh, sorry, Ian, go ahead.
I was going to ask, where was the operating system in these machines? Was that loaded with the tape, or was there another tape that loaded it, or was it preloaded? Was there an operating system at this point?
Oh yes. So on the PDP-11 computer, you had to bootstrap it yourself. So the operating system was on that disk that I showed you, but you had to actually key in 7 instructions on a set of switches on the front of the computer, which with luck we have
I can probably show somewhere.
You here.
Yeah, it's sorry.
There. So you learnt these 7 16-bit words of data, and you flick these switches up and then press load, flick the next one up, load, and then you hit run. And that was, those 7 instructions loaded the bootstrap loader off the first track of the disk, and that then loaded the rest of the operating system off the disk, and then you were away, and it was easy. Luckily, the machines in those days had magnetic core memory, which persists even when you turn the power off.
Wow.
So that meant that if you were lucky, you could come back and the machine would just run when you turned the power back on, using that rather nice key that you see to turn it on and off on the left-hand side.
Now, Peter, you mentioned putting stuff into Titan, and I have to emphasize that I never used this, but I did come across, bear with me a sec, I did come across, when I was looking through the relics cupboard in the computer lab, one of the hard disk platters from Titan. Oh, sorry, bear with me a sec. Oh, I'm going to get all muddled up here. One sec.
While you're getting up, there's some nice comments popping into the chat. So Jonathan says, were punch card palindromes possible?
Feed them in either direction.
Yeah, and we've got a comment from Chris saying, when I started on a Data General Nova, the bootloader was loaded with switches on the front panel, followed by the compiler and OS loaded on a tape.
Well, there we are. It took a lot of time to find this paper tape. I used to have a lot of them, and I realized that actually my children had used them all up at birthday parties, throwing them at each other in the garden. And this is, I think, the only paper tape of its era left now, but it's a valuable relic.
Well, here you go. Here is a hard disk platter from Titan.
Wow.
I actually think that's probably about a 2 megabyte platter.
Yeah,
I think
we reckon it was sort of between 2 to 4 or 5 megabytes.
It would have had 24 of those spinning on a single spindle. And I once worked out that the kinetic energy that it had, should it slip off its axis, was sufficient to carry it through several buildings across the new museum site, which would have been interesting. But we ought to go forwards in time a little bit, I think. People are remarking they used the chads out of punch cards as confetti at weddings, which was probably a health hazard, but probably less so than most things. So after the mainframes, we started getting remote terminals, and particularly the BBC computer came along, which some people will remember, and which actually the lab played a fairly important part in the design of it. We'd been working for some time on thank you, Quentin, on the design of automatic tools to design integrated circuits, semi-custom arrays, and this shows this picture is of the video processor from the BBC machine, which was used partly for speed, partly for cost, and it actually just had a 16-entry 4-bit lookup table and various bits of control circuitry. It was designed by Steve Ferber and Sophie Wilson, and then Jeremy Dion and I actually did the physical design in the department. And if you look very closely at this, in the corner of the chip, you'll see the initials PR and JD, 50 microns high. So 50 microns, about the thickness of a hair, if you have any, is actually on those chips. They only went into the first 5,000 BBC machines because it was actually a bipolar technology which runs very hot, and they had to have enormous heat sinks on them and actually didn't run for much more than about half an hour, but it was quite fun. And we managed to attach to BBC machines mice. Now, mice were interesting in those days because you couldn't sort of buy a mouse as a general thing at your local store. In fact, we imported some of the first mice in the country. We got them made by a Swiss watchmaker, the Depra company. We actually went out, flew out to pick them up and brought them back. And this has beautiful mechanical work inside to make shaft encoders that detect when this ball bearing moves up, down, left, right. And it just gives raw signals out. This isn't really a serial plug, which you could then decode on the BBC machine. So we had graphical interaction. This was in the 1980s. And these then became rather more popular. But actually importing them from Switzerland was interesting. As we brought them through customs, they were x-rayed and they saw these rather strange things and asked what they were. Mice, we said, at which point they said, very well, you'd better go. And it was late at night, so we got away then. But actually, where do we go on from there? Well, I suppose, Quentin, you're next up in time. So what sort of computing did you use when you were around?
Well, when I started on Sinclair's and BBC Micros, but when I was an undergrad, I guess the things that were starting to change, I think I had an Atari ST at the time, but I remember that probably in the second or third year, computers started to become portable, at least computing that we could afford. There were laptops around this time, but they were incredibly big and heavy things. I did use one on one of my summer internships, but I actually wrote my second year, part 2 dissertation on a Sinclair Z88. People might remember these, and I've actually just reached behind me and put some batteries in it, and I discover it still turns on. And these are actually wonderful machines, not least because they have a full-size keyboard and 2 weeks battery life, something like I forget, but it was quite a lot, and connectivity through a serial terminal here. And so I could sit out on the sort of croquet lawn at Harvey Court and pretend to be working on my dissertation. And so I typed it all into here, but this didn't have really any formatting worth speaking of. So I would take this and transfer stuff over the serial line once I'd written the text into my Atari ST, format it with the desktop publishing software of the time, One thing I didn't have at any point in my undergraduate career was a hard disk. But that was, rich people had those, but not me. You didn't have to be too. Actually, throughout my undergrad at Caius, there were only two of us. Kerry Pritchard, who is, I think, also online. Hi, Kerry. Was the other one. And he also had an Atari ST, but he did have a hard disk. And so I could transfer it onto mine, do the basic formatting. But if you actually wanted to produce laserprint or PostScript output, you had to have the software package on a machine with a hard disk. So it basically went from here to my ST to Kerry's ST. Turned out PostScript, and I can't remember how we got that to the laser printer, but somehow I was eventually able to print my Part 2 dissertation. So yeah, and PDAs, of course, were the thing at the time. We were starting to get the Caian organizer and devices like that. So that was one of the big changes during my undergrad time. I never owned a hard disk, but I did own a portable device.
We've got a comment from Steve in the chat saying, I love Atari ST. I developed a credit card payment system on mine. It's lovely seeing some of the comments coming into the chat. Sorry, we're not necessarily calling all of them out, but there are some lovely comments in there.
We are seeing them, yeah. So what about the rest of you? Paula, what did you have as a computer when you, or let's think, who was next? Yes, Paula, when you were an undergrad.
Interesting thing during my time was the rise of the personal computer. I mean, when I started, people didn't necessarily have their own computer. If you wanted to find the computer scientists, you would go to the computer room in the small hours of the morning, and there they would be doing sort of Java tick or something. But that definitely changed during my undergraduate. Things became cheaper and people had their own machines, but not laptops. Usually they would have a massive box, and these was usually sort of Frankenstein monster PCs, which people, you'd put it together from bits you'd salvaged here and there. I think we used to have a lot more discussions about hardware because we were always, putting bits in our own boxes. And the consequence of that was they usually also had some sophisticated and individual cooling system required, or alternatively, you could just heat your coffee on it. But that's definitely something that changed during my time. Laptops were not a thing that everybody had, but by the end of the time that I was an undergraduate, everybody had their own box, I think.
And I think I was there not at a dissimilar time for my undergrad. And I think what was, when I look back, I think the thing that was.
Incidentally, that's what Isabel looked like 20 years ago, completely the same. It is embarrassing.
Yes,
when
annoying,
I look at
isn't
me, now and then. So there they are studying a computing engine, I think, over lunch. The day before exams, we always had lunch out at our house, and you see them working hard there. Sorry, Isabel.
Thank you for the embarrassing picture. What's astonishing when I think back is how network speeds were changing. So I would go from being at home in my parents' house with dial-up, which I imagine quite a lot of people on here remember, which was painfully slow to do anything, coming into my university room to discover I had a 10 meg network connection, which was astonishing. And it's interesting, right? Because it gave me a taste for what was possible with more network bandwidth, right? As in, and it started to let you think about what would it be like if you could just stream things onto your machine whenever you wanted them. And I think what's interesting is to see how long it's taken for that to become mainstream, right? For all of us, now no one questions the fact you've got Netflix or BBC iPlayer or any of those things coming onto any number of portable devices in your house. But it's quite a long journey from, dial up to what we had at university to that becoming the norm for everybody at home.
Well, it's interesting that actually it was about that time in the 1990s that somebody in the lab invented podcasting, mainly because there were graduates of the lab working in California who found they couldn't listen to the Archers anymore. So we set up a server that recorded the Archers from an analog radio receiver, digitized it, and emailed it automatically every day so that they'd have it waiting for them when they got up in the morning in California.
The message from Chris Shaw about using dial-up and having to take apart the phone connections in hotel rooms so that you could connect it up. It's one of those lost sounds of computer science, isn't it? There was that you would spend so much of your interaction would begin with, you know, sort of beep 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 beep, beep. And then you'll be connected, and the modem would switch off. And it's a bit like my father always used to say that the dot matrix printer was another thing, you know, that there was a point where printers made a very distinctive noise, which they don't do anymore. So
but it's interesting, right?
As a computer impressionist, I think this is going to...
But Chris's comment's interesting, because I don't remember dismantling phones. But I do remember travelling with RJ45 cables in case going into hotels, because you never knew what the setup was going to be when you arrived, right? Now you just assume there's going to be Wi-Fi. But then there was no guarantee anything was going to work unless you had your own equipment with you. Ian, we haven't let you talk about your experience.
I think it's really interesting that most of those things that we've just heard about are hardware developments that have enabled a new use of the computer, but they're very strongly driven by hardware developments. And Isabel talking about network speeds improving is the first one that sort of drifts towards the difference in software as well. And for me, in the early 2000s as an undergrad, the thing that was really changing was the expectations we had of software. So the thing that I particularly remember that illustrates that is my part 1B group project was a map applet that we built. And in these days, Google Maps did exist, but it was a static thing. So you could zoom and you could pan around, but these were rendered tiles that you were looking at. And at that point, you couldn't, for example, route from A to B on Google Maps. And so for my group project, we decided we were going to build a map that would let you do routing. And OpenStreetMap existed at the time, which had, of course, all the vector data you would need to do that, but also didn't let you do routing. And so we built a terrible, terrible Java applet, because that's what you used in those days, to allow you to move a map around and zoom in and out and click on your start and end positions, and it would route you reasonably accurately from anywhere in Cambridge to just about anywhere else, if you were lucky. And of course, then a few years later, Google Maps did become much more interactive and vector-based and all of that. But that was really the transition. It was that web sites were becoming the way you interacted with the world, and they were going from being static things that you looked at to applications that you interacted with.
There was no Google during our degree, right? And I remember the first time I ever saw it, and somebody must have said to me, shall we search for this on Google? Because the verb to Google, of course, just didn't exist.
Well, I can remember back in the earlier 90s, so you're right, you pinpointed when the web took off, and you could actually buy a book, meaning a printed book, with the home pages of the 1,000 or so websites in the world. So you didn't really need Google, you just flicked through until you found it. Actually, you could always guess the URL because everyone had the obvious name for their domain, and you just typed it in and odds on you'd find it. That doesn't work so well now.
Well, actually, though, the convention of using your whole domain name to be the thing that just points at your web server, which is just one of your many machines, that's a much more recent thing. And in fact, even using www as the name of the machine that ran your web server. So I think, not sure, but I think I ran the first web server in Cambridge, and it was just on the workstation I had in the lab, which was called Pelican. So the first web server in Cambridge, I think, was certainly in the university, was pelican.cl.cam.act.arc. So it wasn't particularly guessable, but perhaps memorable.
And of course, you just do it on your mobile phone nowadays. It's
So we thought it might be fun if we all found out the phones that we were using when we were undergraduates. So has everybody managed to find their
something close enough?
There you go.
So just after, but not long after.
Classics. Oh, Ian's got a flashy one. I'm not surprised. Which one's that, Ian?
This is slightly. I'm cheating here a bit. This one is an Android phone with a touch screen, which is not actually the one I had, but the one I had did have a full keyboard that sort of flipped out, and so this was the closest I could find.
So what about you, Peter?
Well, I couldn't, because I didn't have a phone when I was an undergraduate. I didn't. Not only did I not have a mobile one, I didn't. We didn't in general have them in college rooms. I think I actually had to become a college employee before I got a phone in my room and was able to even use dial-up. So, no, that was. I did, however, make a phone once. Sorry, this is going out of chronological order a bit here. But when I worked at the Olivetti Research Lab, I was working on VNC, which many of you may know is a way of transmitting frame buffer images from place to place. And I was interested in other things that could be VNC viewers, not just Windows on your computer. And I had this idea that various devices, maybe your car dashboard, might be a VNC viewer. And one of the ideas was that it could be a phone. This is what we ended up making. Actually, I wonder if I may even have a picture of the of an earlier one, which I will show you. But oh yeah, here you go. So sorry, I have to do a bit of shuffling. I'm not very slick on this this here transition, am I? But
while Quentin's shuffling, we can all admire Peter's.
So this is the phone that I actually did have in my college room. It's got a real dial, so it sends pulse dialing. I was lucky because I worked on Varsity as their business manager, as they laughably called me, Jeremy Paxman as editor, which was a disaster. I actually had a real phone, so I could phone people and make business calls, except actually I couldn't make calls outside the college, so it was more useful for incoming calls, except each college had its own telephone exchange, a mechanical telephone exchange. And so one of the features of this was there were special short codes that would take you across to a different college. So if you wanted to go to some other college, you'd dial a 7 to get onto the inter-college network, and then dial the college number and then the extension within the college. And I discovered that there were some colleges in Cambridge that didn't give undergraduates phones, and so they didn't block external calls. So in fact, if you jumped across a few colleges, you could actually find somewhere where you could then dial 0 and get an outside line rather than the operator. And then you could dial trunk calls for free. Well, cost to some other college, I fear, but never mind, that's life.
Well, I have failed to make my fancy screen sharing work. So let's just see if I can do it this way. Bear with me a sec. If this takes too long, you can shut me up and I can go somewhere else. So,
yes.
Can we see that?
We can. Yes.
We can. There you go. So this was the prototype. This is actually a small laptop here, which we went to PC World or something. We bought a BT big button phone. We cut the insides out of it, massacred this laptop and put it in, and we had a touchscreen based phone, which was also, it was basically a VNC viewer. So the idea was that thin clients had worked very well for the audio. A phone was just a microphone and speaker and nothing else. And so wouldn't it be good if the phone exchange also generated the graphics? And so this was basically a VNC viewer. And at about that time, the Olivetti lab was bought by AT&T, and suddenly anything that was phone related became, terribly interesting. And so we ended up making, gradually improved versions of this. And not very slick here. There you go. So this was this thing actually in operation. And going back to our ideas, what we were saying about interacting using drawing, this was a very good way of doing that. The killer app was the fact that when you were on the phone to somebody at the other end, you could draw things while you were talking about them, and they would say, "Oh, where is the entrance to the lab?" And you'd say, "Oh, well, that's actually around here," kind of thing. And you could draw while speaking, and that was a killer app. But
you said this is all VNC based, right? So
this is all VNC.
How are we interacting here?
So what you're actually doing here is, yes, this is VNC. There is some software running on the phone exchange, the local phone exchange in your organization, that would generate these VNC screens. And it was lovely because in general, VNC was a way of taking an existing desktop, compressing it and sending it over a wire. This was actually a graphics toolkit that was never displayed on a local frame buffer. It just knew how to generate VNC. So you would say, put a button here, and the button didn't actually know what it looked like. It just knew how to send the right bytes over the wire. So it was phenomenally fast. And these became our internal phone network for a while, and it was going to be a spin-off company, but sadly the lab closed down just before that happened. But one of my favorite little slides on this was that I wanted a mobile version. Now, I couldn't actually have a mobile one that I could walk around the street with, but I did want, but I could make one with Wi-Fi in it. So about that time, we had the compact iPac PDA, and you could put a Wi-Fi card into it, and you could make a version of this, because they both ran on ARM processors. Let's just see if I can. Sorry, I've got too much rubbish on my screen.
Here's that sort of thing. So here's my early PDA, and it even has a screen and yes, there we are, the same Wi-Fi chip plugged into it. Yes,
there you go. So I don't know if you can see this, but on the left is the little mobile version of this that I made in 2002. And I've always liked the fact that a little while later, a larger company came up with something. This is my hand on the left. I don't know whose hand it is on the right, but it looks remarkably similar. And it's I think, natural, because anything you can make that is palm-sized and has buttons that are finger-sized are probably going to have 4 buttons across and be about that sort of ratio. But there you go. I like to think we were a little bit ahead of our time, at least. That's my only phone.
Paula, your work with language, of course, is important on phones when we're trying to actually send written language or maybe even understand natural language.
Yeah, well, I've had a bit of a journey with language on phones. So back when I had the old classic Nokia phone, you remember these phones were when predictive text meant you keyed in some numbers and it predicted what word you meant from the numbers you typed in. And that was revolutionary, because before that, in order to get the letter C, I'd had to press the number 2 3 times. So yeah, that was predictive text, the T9. That was really, really exciting. But of course, there was no language model. There was no contextual information on the phones. But yeah, back where these were popular, that's when I had my first consultancy. And that job, what was that? The company there, this is going to seem so dated now. What you had to do, you could text this company your question, and they would send you an answer to your question back to your phone via SMS. And of course, this was a sensible thing to do because we didn't have data on our phones. And so, yeah, how this worked was you'd send the question, and this startup had invested quite a lot of money in developing software which funneled your question to an expert, a techspert, in fact. And then they would look up the thing from the comfort of their own home and then send you a text back. I seem to remember this cost you £1 a time, but it was really, really useful if you wanted to know when the next train was, because of course you just didn't have the internet in your pocket at the time. So typical Cambridge story, I met the guys who were running the startup in my local and started talking to them about it. And it turned out that a lot of their questions were quite formulaic. So with a bit of natural language processing, you could probably automate quite a few of their questions and semi-automate a few others. And what's interesting about this is how far the natural language processing technology has changed since I was doing that to now. So at the time, it was really good, wholesome computer science, because I was parsing these things into a directed graph, and then I was traversing the graph, good algorithm stuff. But now my day-to-day is mostly dealing with numerical methods, because natural language processing for the most part is machine learning. It's all about machine learning. Although we do actually still get to deal with nice knowledge graphs when we're doing some kind of information retrieval. But yeah, the idea of texting somebody to get an answer back on your phone seems, absolutely ridiculous these days. But of course, this was just the precursor for when you type in a question to Google and the information pops up in the information extraction box, or if you're talking to Alexa or Siri, it's just the same thing, just with a bit of ASR on the front. So, but it's really interesting to see how the natural language processing has completely changed since those times.
I must just throw in, Chris Shaw has just commented that the food distribution company 3663 got it named because if you're using predictive text, 3663 spells food. Useful thing to have learnt this evening. Thank you, Grace.
I think Paula's observation of, I mean, obviously it's amazing how language processing and stuff has changed, but it's also incredible to note how much is on the internet now, right? I mean, some of you guys will be accessing this webinar via the web interface, right? You don't necessarily need an app. And it's, you know, Ian, earlier you observed some of the early discussions we were having about how hardware evolves, whereas actually a lot of the leaps and bounds we're seeing now are in terms of information accessibility and how we get it and what you can do with it, which I think has led to what you're doing these days, isn't it?
Absolutely, yeah. I mean, Quentin must have been, you were computer officer at Keys, right?
I was, yes. So
when was sort of networking being generally installed in Keys?
Well, let's think. This was 89, I guess. I became computer officer, and just you know, we were talking about owning our own computers. I had been sort of helping out with the college computer rooms. There was one, you know, like 3 or 4 rooms down to me, and I would help students who were lawyers or other things, you know, format their stuff so that they could print it out on a laser printer. One person I remember needing quite a lot of help was a certain Pippa Rogerson, who obviously it was now master, and obviously my you know, my assistance with her PhD printing was clearly foundational to great things. But after I had another job lined up when I finished my undergrad, I was going to go off and do that. But I got talking, I think it was probably to Michael Pritchard, who was senior tutor at the time, or might have been to John Robson. I must confess, I forget, but I see John's son, Tom, is online. Hi, Tom. And I said, you know, you really need somebody full-time to help look after all of these computers. People are using them quite a lot now. And he said, yes, we do, don't we? And went off and came back a day later and offered me the job. So I became the computer officer at Keys. I think I was the first computer officer at any Cambridge college. And we had at that point about 100 PCs in the college, which was very unusual. Most colleges had, you know, a dozen or fewer, and they were actually, I've got a picture here, these were Olivetti M24s, which looked like that, which were very PC compatible, but actually faster than the standard IBM PC. You'll notice it has 2 floppies. I don't think in general we gave people hard disks, but there are 2 floppy slots on there. And we had about 100 of these in the college, and almost none of them were networked. So some people had modem cards in the back, and they could plug into the network and they could dial up the CUDN, the Cambridge University Data Network, or using their modem, and that was how you got connectivity. But we were just starting then to install networks, or there were networks installed in the tutorial office and the admissions office. Maybe the bursary as well. I'm not sure when they got one. And the main reason you installed a network then was because a laser printer was really expensive. And so if you wanted several people to be able to use the laser printer, it was useful for them to be on a network. But that was, you know, the key reason. Those networks weren't connected to anywhere else particularly. It just allowed the machines in an office to communicate. So yes, but at that point, I think it would have been 10 megabit Ethernet, which ran over coax cables. And we weren't at all sure whether Ethernet or token ring or some other technology was going to be the thing that took off. We happened to go for Ethernet, and as it turned out, we were right. But yeah, so that was very early days. And the rest of the college, I remember in the library, we had serial terminals which would connect you to the UL catalog. So these were more like sort of VT100 type dumb terminals. They were connected to a serial concentrator. And I actually, Peter might know, I actually don't know what the connectivity some sort of X25 connectivity between those and the UL, or
yeah,
somewhere?
the university was running its own X25 data network over rented copper wires, rented from British Telecom, which of course then gave a brilliant man called Chris Cheney, who worked for the computing service, the idea that it might be worth having a university network that we actually owned rather than renting it from BT. And he used to suffer from migraines, and one day he was out walking, trying to clear his head, and he realized that he'd walked a long way around Cambridge entirely on college or university land. And the law in those days was, if you wanted to run data cabling, you could do it between two bits of property that you owned, even if it crossed a public highway. So he worked out that he could join up the whole university if you dug something like 25 kilometers of trench around Cambridge, and managed to persuade the colleges to work together on this, which was an incredible achievement. And better still, actually, hired my late wife, Carol, to assist as the project manager. This was installed. So she spent 2 years supervising gangs of Glaswegian navvies on piecework as they excavated their way through a World Historic Monument. It was the best years of her life, you know, the days when they went through a 25 kilovolt cable on the Downing site, not good, it turns out, or the day the hydraulic digger burst the digger burst a hydraulic pipe at the front of King's Chapel and sprayed oil over King's Chapel. Didn't go down well with the fellows. Or indeed the day they were digging in quays, going across in front of my room in P staircase, and went through a water main that wasn't shown on the plans. So I invited Carol in for lunch, and we admired the fountain before we went in. But, yes, anyway, and it proved a great benefit, especially as the use of the internet took off. It's interesting. I think, Quentin, you've got some figures somewhere that show how, through a relatively short period, the use in particular of HTTP as the web took off through the 90s had a fairly dramatic effect on the internet.
Yes, I remember seeing and playing with the first graphical web browser, Mosaic, when that would have been 92, I guess. And thinking, oh, this is quite cool, and looking into the protocol, and it was very simple. So you could write your own web server as a sort of bash script, pretty much, and I thought, oh, I think this could take off, kind of thing. And at that point, the National Science Foundation in the States would publish each month the statistics of the different protocols, essentially the different ports that were in use on their backbone network. And I remember looking at this, and at the top was, I think, FTP or maybe email, and then there was a whole load of these, and at 118 there was this thing called HTTP, and I thought, I'm going to keep an eye on this. And I actually wrote a cron job or some sort of script that once a month would capture these statistics. I wish I still had the numbers. I don't. I've lost the data. It's tragic. But you could see HTTP was like at 118 one month, and then the next month it was 100, and the next month it was 70, and it was like a horse coming from the back of the race, charging up, and it was, you could tell it was gradually going to eclipse stuff. And I thought, maybe I think this web stuff is going to take off. Actually, it's great fun.
It's interesting that as that happened, I suppose it's not a coincidence that as that happened, the software that we tend to use migrated from being desktop software to being web software. And like I said earlier, things like Google Maps turning into an interactive tool, it was really turning from, like I said, being a thing you look at to an actual application. And one of the things that was around and very big in the 90s was Visual Basic and Delphi and those kinds of tools.
I used those in the Keys offices, actually. Yeah, we had things that ran on it.
Well, there you go. And there are, they were amazing tools. And in fact, there are billion-dollar companies that still run on things written in Visual Basic, and Microsoft have committed to supporting them out till the 2030s because there are companies that rely on it so much. But something that interesting was that those tools didn't make it onto the web. Visual Basic is very much a desktop tool, and it allows you, if you know a little bit of code, to build things that are essentially real applications. They look like every other application on your computer, and you can give them to all the employees in your business and run your company on a tool that somebody who knows a bit of BASIC built. Of course, that left a gap once everything had moved onto the web. And so this is what I've been doing for the last few years, is essentially trying to build Visual Basic for the web. And so that's what has become my startup, Anvil. And we essentially make a tool that allows you to build full stack web applications entirely in Python. And the fact that it's Python is a bit incidental. It's just that it is one programming language and lots of people know it. But I don't know, let's start with Peter. What programming languages, once you were writing in a text editor as opposed to on punch cards, what were you mainly using?
Cards, I was using Fortran, and then on Titan, it would have been Algol of some flavor. But the main work I was doing on the PDP-11, all the work for that vector general display that you saw was in BCPL. Of course, Martin Richards' invention, which became, was picked up, was the first language used at Bell Labs for their work on operating systems, and they then wrote C as a derivative of that, and Unix. But in fact, a lot of their work ran on BCPL to start with. Interestingly, so did the work at the Xerox Palo Alto Research Center on the workstations, the Alto workstations, actually used BCPL in the first instance before they went on to their Pascal derivatives called Mesa and Cedar.
So for quite a lot of history, most of
nowadays I use Python on Anvil mainly, or Jupyter notebooks.
So most applications for most of the history of computer science have been written in a single language, mostly. And something went wrong when we moved onto the web, because if you want to build an application, you need to write HTML and JavaScript and CSS, and you need to understand Angular and React and Redux and Django and Flask and SQL and SQL Alchemy and Postgres and Linux, and how to run a server and how to keep it updated and how to keep it secure. And we've moved into this world where it's just bonkers the amount of stuff you need to know to build this.
And ideally, you don't want to be a computer scientist, right? Because it's all pervasive, and it'd be wonderful if lots of people did CompSci, right? But not everyone does, and somehow everyone needs to be able to do this.
That's right. And of course, there are other problems. If you, well, even if you let computer scientists write the code, just because you've moved everything onto the web doesn't actually mean that all the applications that people write are either do exactly what they wanted them to do, or that they do it securely. Now, doing it securely wasn't such a problem in the olden days when nothing was connected to anything else. But it is more of a problem on the web, which is kind of Isabel's
Indeed,
domain.
and it's an interesting conjunction between what you're doing and what I'm doing at Garrison now, because as you're enabling, right, you enable everyone to be able to get stuff onto the web. But the fascinating thing is we have more on the web and more reliance on the web. It is also the easiest way for malware to come into any organization, right, and onto our endpoints, because you're basically inviting someone else's code to execute on your machine. And that code is sat on top of a web browser, which probably in itself is, I don't know, say 10 million lines of code sitting on top of an operating system with another 50 million lines of code, which leaves you wide open to exploit. And this is where what we're doing is quite interesting from a computer science point of view, because actually we're trying to turn things around. So, using cool Turing machines, which are capable of doing everything, is awesome, but it is also inherently vulnerable, right? Because it just takes a persistent attack, of which there are quite a lot in the world now, to spend enough time finding a vulnerability. So what we're trying to do at Garrison is actually turn that around and say, yes, absolutely, do all of these cool sorts of things in software to enable, but don't do the security functions there. And where you're actually enabling security functions, let's take a step backwards. Let's use non-Turing machines, so simple automata with, which are in effect too dumb to hack, right? Because you can go through them and you can work out precisely what they are going to do, use them to secure your boundary, and only pass through stuff that is safe. So actually, Quentin, you were talking about VNC and screen buffers and stuff earlier. And that's precisely what we're trying to do, right? So let's turn the internet into something safe that you can ingest. And pretty much the only thing you can do is to turn it into raw bitmaps, raw audio, and to generate a video of those, which is what we do. And then we allow people to click and type like you would on a normal thing. And actually what you end up with is quite a natural user experience, but under the covers, you've got a really secure boundary, taking kind of a step back in terms of moving away from software and moving back into the hardware arena to enable that.
Can I show you a wonderful video to illustrate this?
Yes. So the video that you're about to see there is how we try to explain this to everyone, which is to say, in an ideal world, you just want to unplug from the internet. But you can't unplug from the internet, right? Because everyone uses it. So instead, what you want is a robot who can browse the internet for you. And that robot we have in our offices. We are, of course, all geeks and love to have a robot. And that robot browses the web for you. And the robot has a camera in its chest plate. So everything the robot sees, you see. But there is a complete air gap between you and the internet because he is the one accessing it. His machine is the one that's going to get compromised. And all you get on your machine is the video that he's seeing. Now, clearly, we are not selling robots. That would be quite an expensive way to secure the web, although potentially a cooler way. But what we are doing, and actually it's interesting because we've kind of gone all over the place with this conversation. Not only are we trying to take a step back in terms of simplifying how you do security to make it more effective, but actually all the evolutions we've talked around mobile phones and stuff have made what we do possible, because we've also got a whole load of ARM chips in there generating the screen that we're transferring across. So it's
I'm sure
everyone loves a robot, right?
The main use of robots is for publicity.
Absolutely.
I've been aware of that. The research work I've been doing, which I do a bit of over the past 20 years, has been looking at trying to give computers some sort of emotional awareness, social signaling, so monitoring people's face to see their facial expressions, understand what they're thinking, mental states, tone of voice, body posture, and even to make computer systems. We thought it'd be good to have a computer system that displayed them. So we got a very expensive robot made with rather good prosthetics and a couple of dozen motors inside that replicate the muscles, and tried to have people interact with it. And the answer is they just find it plain creepy, and it's a complete disaster scientifically. But it is brilliant for publicity. If you have a robot like this, here you see Ian and me appearing. Would you believe it? On the drawing to a close, I think take one or two of the questions perhaps. So I think this is a really interesting one. Ollie Chick has answered. What do you think we'll be laughing at in 2021 when we, of the 2021 technology, when we're celebrating 60 years of computer science at Keys? Well, go on, Paula. You're the future of the subject, probably, aren't you? What do you think you'll be looking back at and laughing at?
Oh my goodness. I'm not sure. Does anybody have an answer to this?
One question is there going to be something that comes after Swiftkey, for example, that's the next, we've gone from T9 to touchscreen keyboards. Is all that going to be replaced by speech recognition? I would say not, but what are there other interaction techniques that we haven't thought of yet?
Well, yeah, I mean, did you see if, what's his name? The Tesla guy. I forgot
Elon Musk.
In the press this week, he's actually managed to wire up some sort of animal to play video games, right? So, I mean, presumably this is the next interface directly into your brain.
Ah, yes. Now, kids will be saying, what, you mean you actually had to look at a screen? It wasn't just, back projected straight onto your optic nerve. Oh, and the college, that was that place where you used to have physical gatherings, wasn't it?
So I think I have a couple of ones for this. I think But particularly this year, I would hope that we'll be looking back at 60 years going, gosh, can you imagine how basic it was doing whiteboarding sessions back then? You know, we started this whole session on how difficult it, well, mixed results in terms of using virtual whiteboards and stuff for interviewing. I would hope that was something we can look back on and go, oh my gosh, that was so basic back then. I think, and coming to what you're talking about there in terms of interactions, I hope the other thing that we can laugh at then is how frustrating. So I'm quite, she's going to ping now, when the number of times I say, Alexa, please do something or other, and she has no idea what I say, does completely the wrong thing or ignores me, and then someone else in the household steps in and does exactly what, and she does exactly what she's told. I'm hoping, again, this will all be, you know, completely, you know, we can just walk around and go, turn that on, do this, add this to the list, and that will be seamless rather than painful.
Another question that's come in is do you think you can make the case that the whole history of computer development has been dreams of programmers being held back by inadequate hardware? To which I'd say, well, actually, possibly, and certainly the way that I've done research over the years, at least once I twigged this was the way to do it, was to pay a fortune for expensive hardware. So buy yourself 10 years into the future in terms of hardware, and then see what it did. And you could then do experiments. So Quentin's work with Brightboard, you must remember, in those days, you couldn't buy a webcam. Quentin hadn't invented the thing. We actually had to buy rather expensive television cameras and digitizers and the most expensive personal workstations. But it meant we could actually explore what might work. So yes, I think what you've got to do is have people who are prepared to spend money on eccentric hardware. Although it has to be said, some of it, like robots, not a good idea, but some of it is good.
But I think there is also an element of what's managed to get the most publicity or had the most marketing thrown at it, right? Because, you know, you showed that the examples you showed, right, made it quite clear that we could be miles ahead in terms of virtual whiteboards and things, right? But that hasn't been where there's investment, right? Because it hasn't been that same need. And similarly, I think it's slightly terrifying in some ways, right? Very powerful marketing machines can push us in an entirely different direction to what we might naturally evolve as computer scientists.
Well, I have a really very poor track record for spotting the future, so I really shouldn't be speaking, but I can tell you things that I've failed to spot. Like Stephen Hawking had a collaborator who used to come over from Stanford to work with him called Nathan Myhrvold. And on one of my visits back to California to visit Xerox, I thought, Nathan Myhrvold's at Stanford. They've got a linear accelerator. They're fun. I'd like to see one of those. So I went to visit him. And he didn't really want to show me the accelerator. What he wanted to show me, this was in about 1983, was an IBM PC, which had just come on the market. And the original IBM PC had a screen that was sort of like punch cards. It had 80 columns and actually had 24 lines of text on it. And he said, nobody's going to want to use this. They're going to want to have more than one program running at once in little portions of the screen, which was exactly what was happening down the road at Xerox. And he said, so I've made a little system for this that allows you to have little windows with 8 rows of 20 characters of text on the screen. And I said, well, yes, you're quite right. That's the way people are going to want to interact with computers. But it's just the wrong hardware. This was an 8086 processor. You want a real processor like the ones they use at Xerox. He said, well, no, I think people will buy it because it's made by IBM. So I'm going to leave Stanford and set up a company. Would you like to join me? Well, I just got my job in the department. So I said, well, that's fun, but no, it's okay, thanks. So the next time I saw him was in about 2000, when he flew into Cambridge in his private jet to give a check for $20 million to the department for our new building. It turned out his system had become Windows, he'd been bought by Microsoft, he'd become the vice president in charge of research at Microsoft, and was coming to deliver the Bill Gates check for the William Gates building. So I'm not good at spotting the future. And I guess there are a number of, well, Quentin invented the webcam. We thought, well, that was fun. We perhaps should have patented it, but we didn't. And so on and so on. I don't know.
I have another one actually that I realised thinking about what of today's technology we might be laughing at in 10 years. And one of the things that's kept me sane while locked in my house for the last year is playing with Raspberry Pis. So I've got a lot of these around the house, and the Raspberry Pi Zero in particular, I think, was extremely revolutionary because it's cheap enough that you don't mind blowing it up. And I think an interesting question is, what is going to be cheap enough that you don't mind blowing it up in 10 years' time? And I suspect the amount of processing power you can get into something that costs £9 is going to be very interesting to see in 10 years. So I'm looking forward to that.
So an interesting comment come in on, and I think this is an answer to the question of what will we laugh at? And Guy Hayworth says neural networks. And I think that's a very fine note to end on, because David Wheeler, who we all revered enormously, having invented most hardware and software that to speak of, knew about neural networks. And he said, well, they're the second best way of solving any problem. So it'll do, but actually there's probably a better way of doing it. And so I think that may well be something that we'll look back on and wonder about. Oh dear, yes, well, other comments are flying in. I
think we should call it a day.
8, I don't know. Yeah, all right, I'll just mention this. The disagreement about hardware and software. Chris Barrington Brown thinks that most computers are just wasting cycles, waiting for programmers to use them, which is possibly true, yes. And actually, even when they're doing things, they're wasting power executing instructions speculatively, because that's the way you make them fast nowadays inside. But
something that came up during our preliminary discussions, we were talking about how hardware has changed phenomenally since the 70s, but actually the things that people can think of to do with it haven't changed as much. And so in that regard, actually, yes, it sort of makes sense that most computers are spinning, not doing very much, because the hardware has progressed faster, and particularly in things like interaction, we haven't got that much better at it.
But I think Chris's point is interesting, right? Because there are so many spare cycles. I think it's changed the way people approach programming, potentially to be slightly more lazy about it, right? Because I mean, I can remember conversations I've had with developers going, well, is that actually going as fast as it could go? I don't know, that's how fast it went. But, well, how fast theoretically could it go, right? Given the constraints of what you're trying to achieve and the hardware you're running on. But because there is quite often more CPU grunt there than you need, I think people start to forget about that, right? And make it, and don't necessarily go back to first principles.
The practical upshot of that is that Peter's light pen has a lower latency than my iPad and pencil.
Yes, I mean, the stuff I wrote for the Brightboard thing, which was basically looking at each individual pixel, you know, in modular 3, which was reasonably fast but not super fast, and I was very conscious of exactly, you know, what resolution of image I was trying to analyze at this point, and then when I'd done the basic analysis, then try it on a slightly higher resolution, and then whereas now you can just throw in OpenCV and just say, what characters are on this board, or something like that. I mean, I think in trying to predict the future, you know, I often get asked this about the web, and my friend John Norton has always said that the key thing about the web was that it was a machine for surprises, surprise generation machine, basically, because of the way it was designed, because there were no constraints on it, really. It was there. You didn't have to license it. You didn't have to get anyone's permission to create stuff on it. Anyone in the world could do it and could share it with anyone in the world. And so it was so open in that sense that it was natural that surprising things happened with it. And that, in fact, if you could predict what was going to happen next, then it wouldn't be the web. This is what I usually tell people that they are. But I wonder whether there's a current technology for which that's true. You know, is that what will happen actually in 10 years' time, people will come back and say, do you remember when there was a web outside Facebook? You know, so terrifying thought. But I do wonder whether there's, you know, if there's stuff being created now that will give such scope for new things to happen, and maybe it is neural hardware basically.
Quick comment on this that we haven't addressed in that discussion is the sort of social aspects of what might constrain us in the future. So increasingly, I mean, we hear all this stuff about social media and the sort of backlash that's coming about that now. So that maybe will change the way we're interacting on the internet. But I'm increasingly seeing students tell me that they don't want to use the high performance computing cluster because of the environmental aspect of that, and they'd rather do a different project that didn't require using that. So that's an interesting aspect of what might change how we develop in the future.
Yeah.
People will think about the carbon footprint when they do a Google search. We must draw to a close. Well, thank you all very much. I do look forward to the time when we can meet in person. And I hope with many of our guests we'll come back and we'll actually get together for dinner in the newly refurbished kitchens in Keys, which are lovely, but alas, we're not allowed to use them at the moment. I'm touched by a message from John Shapiro, who says he's not sure if it's cheering or depressing how young you all are. Well, 3 of you anyway, he says. Which is true. But anyway, Quentin, Isabel, Ian, Paula, thank you very much indeed. It has been great fun. And I think we could possibly carry on indefinitely, but we'll do that over dinner in some more appropriate circumstances. So thank you all very much.
Thank you for joining us.
Thank you.
Bye then.
Bye.
Bye.